Every time you pick up your phone or start your car, or even just turn on your computer, you're tapping into a world built on silicon. But what most people don't realize is that behind that world, there's a hidden layer, a very small group of, let's call them secret gatekeepers, who control the actual blueprints for all of modern technology. They run a market you've probably never heard of, but if they disappeared tomorrow, the digital age would just grind to a halt. So to really get a sense of their power, you gotta look at the scale of what they enable. The global semiconductor industry. It's worth over $660 billion. It is a colossal engine for the entire modern economy. But here's the thing. That entire massive engine is completely dependent on a much, much smaller and way more concentrated industry. And this is that industry. It's the market for electronic design automation, or EDA for short. This is the super specialized software that's used to design computer chips. The whole market is worth about $19 billion, which sounds like a lot, until you see that a stunning 74% of it is controlled by just 3 companies. I mean, this is one of the most intense, pure oligopolies in all of tech.
Okay, so let's dig in here. Why do these companies have so much power? Well, it's because they solve a problem that is, for all practical purposes, just impossible for a human being to solve on their own. Think about this for a second. Imagine I asked you to design an entire city. I'm talking every building, every single road, every last water pipe and electrical wire, and you have to get it 100% perfect on the first try. Because if a single wire is out of place, the whole city goes dark. That is the scale of modern chip design. We are talking about billions and billions of transistors, where just one tiny mistake can turn a $10 million batch of silicon wafers into a pile of very expensive, very useless coasters. So, to even try to manage this insane complexity, engineers have to follow a process that looks something like this. It takes you all the way from a high-level idea down to a final file you can send to a factory. But each one of these steps, from creating the logic to physically placing and routing millions of tiny components and then verifying that all of it actually works, each one requires incredibly sophisticated, automated software. And these aren't just simple programs. They're the result of like 30+ years of intense research and development.
So, who are the companies that make these absolutely essential tools? It's time to pull back the curtain and meet the 3 gatekeepers who basically run this entire critical market.
Okay, so here's the breakdown. At the very top, you've got Synopsys, with 31% of the market. They are famous for their design compiler. It's literally the gold standard for logic synthesis. Right on their heels is Cadence, with 30%. They are the undisputed kings of analog chip design, thanks to their Spectre simulator. And then there's Siemens EDA, which was built when they bought a company called Mentor Graphics. They hold about 13% of the market, and their crown jewel, a tool called Caliber, has a near monopoly on that final critical step of physical verification.
And get this concentration of power, it's only getting more intense. In early 2024, Synopsys announced it was buying Ansys, a leader in a related field, for $35 billion. This is set to be the biggest acquisition in the history of the entire industry. It's a clear signal that the big guys are actively getting bigger, and they're building the walls of their fortress even higher. Now, as you can probably guess, that kind of market dominance comes with a price tag that is, well, truly staggering. Let's talk about what it actually costs a company to even get in the game. $2 million. Yep, that can be the price for a single license for some of the most advanced software out there. And that's not a one-time thing you just buy and own forever. Oh no, that $2 million figure is for what's called a seat license. And the concept is really simple. It gives one single engineer the right to use one specific tool for 1 year. That's it. It's one of the highest per-seat software costs in the entire tech world, by a long shot. So let's just put that into perspective. A medium-sized design team, maybe 20 engineers or so, doesn't just need one tool, right? They need a whole collection of them for synthesis, for verification, for implementation. So you do the math. Their annual software bill can easily blow past $20 million. And for the huge players like Intel or Apple, we're talking hundreds of millions per year. Okay, now here is the real kicker. After you pay all that money, millions, tens of millions, the license agreements have clauses that look just like this. The tools are provided as is. What does that mean? It means if a bug in their software causes your $10 million chip design to completely fail, the vendor isn't responsible for your manufacturing costs or your lost profits. Nope. Their liability is capped at the license fee you paid them. The bottom line is, the customer, the one paying millions, carries almost all of the financial risk.
So why? Why do companies put up with this? Why hasn't some scrappy startup come along and just disrupted this whole market with cheaper, better tools? Well, it's because this oligopoly is protected by some of the deepest, widest moats you will ever see in the business world.
Let's break down these fortress walls. First, you've just got decades of insane technical complexity. I mean, these tools have algorithms that have been fine-tuned since the 1980s. Second, the R&D spending is just astronomical. The big three spend a combined $2 billion a year just to stay on top. Third, the cost for a customer to switch is huge. Their entire workflow is built around these tools. Trying to rip one out is, as one person put it, extremely disruptive. And finally, a dense forest of patents protects every little piece of their intellectual property.
And what's the result of all those moats? Well, you're looking at it. It's extreme customer lock-in. For companies like Synopsys and Cadence, somewhere between 85 and 90% of their revenue is recurring. It just comes in automatically from existing customers locked into multi-year contracts. Once you're in their ecosystem, it is very, very hard to get out.
For decades, this has been the story, one of the most stable, predictable, and, let's be honest, profitable corners of the entire tech industry. But now, several powerful new forces are showing up that could, for the very first time, actually start to challenge the status quo and push us into a totally new era.
The first big shift is the move to the cloud and AI. You know, the old way was you'd buy a fixed license and run it on your own expensive servers. The new way, you can access these tools on the cloud and basically pay for what you use. At the same exact time, AI is being built right into the software itself. Synopsys claims its AI tool can dramatically boost a designer's productivity, which could fundamentally change the economics of how chips are made. But maybe the single biggest threat to the old guard is the rise of a credible open-source alternative. This is the OpenROAD project, and it's getting a lot of funding from government programs like the US CHIPS Act. Its goal is to build a complete end-to-end chip design flow that is totally free. Now, it's not as powerful as the commercial stuff for the absolute bleeding-edge chips yet, but it has already been used for over 600 successful chip designs, and it's starting to democratize access for universities and smaller startups that could never afford the old way. And that leaves us with the big question, doesn't it? For 40 years, this fortress has seemed completely unbreakable, protected by its own complexity, by insane costs, and by customer lock-in. But now, for the first time, you have three major disruptive forces: AI-driven design, flexible cloud computing, and a real open-source movement, all hitting at the exact same time. So, could this be the moment? Could the walls of this powerful, hidden digital kingdom finally begin to crumble? The future of our entire technological world might just hinge on that answer.